In this tutorial, we are going to talk about the concept of flotation. Having discussed the concept of density and relative density in our previous tutorials, you are going to find this topic very interesting. If this is your first time visiting our channel, you are very welcome. But in order to catch up with us, you have to at least watch our video on density and relative density. The link is in both the description and the comment section for you. Now let's jump right into the topic. Let's start by recalling some essential facts from the concept of density. We know that every liquid has its own density, and an object will sink in a liquid if its density is greater than that of the liquid. However, it will float if its density is less than that of the liquid. Now let's examine this setup to establish some additional information about the concept of flotation. In the setup, we have 3 containers of water, initially of the same level. 3 different objects, namely a cork, wood, and metal, are put in them. We observe that 2 of the objects, that is the cork and the wood, float, but the metal sink in the water. We also observe that the cork and the wood that float differently. So we can derive 4 essential information from this diagram. Number 1, if a body would float in a liquid, the density of the liquid must be greater than that of the body. Number 2, when a body floats in a liquid, a fraction of its volume goes below the liquid and a fraction of its volume remains above the surface of the liquid. Number 3, a floating body displaces a volume of the liquid, and the volume of the liquid displaced is the same as the volume of the body below the surface of the liquid. This third point is very essential for our understanding of flotation, and so I take it again. A floating body displaces a volume of the liquid in which it floats, and the volume of the liquid it displaces is the same or equal to the volume of the body below the surface of the liquid. And number 4, which is also very important, the volume of the liquid displaced is directly proportional to the volume of the object below the surface of the liquid. This means that as more of the volume of an object is below the surface of a liquid, the more volume of the liquid will be displaced. A careful analysis of the setup will show you that the fraction of the volume of the object below the surface of the liquid is a ratio of the density of the object to the density of the liquid. So we can write a simple equation out of this, that is, fraction of the volume of object immersed in a liquid is equal to the density of the object divided by the density of the liquid. Let us name this equation 1 because it is going to be very vital as we do some computations. Now let's expand more on the concept of the fraction of the volume of the object immersed in the liquid. Assuming that the volume of the object is VO and the volume immersed in the liquid is Vs, we can write that the fraction of the volume of the object immersed is equal to the volume of the object immersed divided by the total volume of the object. And so using the symbols above, we can write that the fraction of the volume of the object immersed is equal to Vs divided by VO. That is the volume of the object submerged divided by the total volume of the object. Now let's name this also equation 2. This means that we have obtained two different but the same equation for finding the fraction of the volume of an object immersed in a liquid. And so let us equate these two equations. We are going to get the volume of the object immersed divided by the total volume of the object is equal to the density of the object divided by the density of the liquid. So let's write this equation in symbols. We are going to have Vs divided by Vo is equal to rho O divided by rho L. And these two equations are what we need in trying to solve questions under the concept of flotation. Now we are going to condense all that we have said so far into one single sentence, and this single sentence is called the law of flotation. So what does the law of flotation state? The law of flotation states that a floating body displaces its own weight of the fluid in which it floats. I take it again. A floating body displaces its own weight of the fluid in which it floats. This law simply means that for a body to float, it must displace an amount of the liquid in which it floats, and the weight of the liquid displaced is equal to the weight of the body. Now let's write a mathematical equation out of the law. We can write that the weight of the floating body is equal to the weight of the liquid displaced. From our previous tutorial on density and relative density, we saw that the weight of the liquid displaced is equal to the density of the liquid times the volume of the liquid displaced times acceleration due to gravity. Since we know that the weight of an object is the product of the mass and acceleration due to gravity, we can substitute and say that the weight of the liquid displaced is equal to the mass of the liquid displaced multiplied by gravity, and this will give us the density of the liquid multiplied by the volume of the liquid displaced times acceleration due to gravity. And since acceleration due to gravity is on both sides of the equation, we can divide both sides of the equation by the acceleration due to gravity. And in this case, we are going to arrive at the mass of the liquid displaced is equal to the density of the liquid multiplied by the volume of the liquid displaced. This is the beautiful concept of flotation. Now let's do some computations. Our first question reads, a block of wood of mass 25 kilograms and volume 3.2 times 10 exponent minus 2 cubic meters floats in water. What is the volume of wood above the surface of the water? And the density of water has been given as 1000 kilograms per meter cube. So let's see how we are going to solve this question. First of all, let's put down the information given in the question to help us analyze it well. We have been given that the mass of the wood, which we are going to represent by MW, is equal to 25 kilograms. Also, the volume of the wood, which we are going to represent by VW, is equal to 3.2 times 10 exponent minus 2 cubic meters. Now let's write this in decimals to make our computations easy. We are going to get 0.032 cubic meters. We have also been given that the density of water, which is a constant, rho WO, is going to be 1000 kilograms per meter cube. Okay, now the question is asking us to find the volume of the wood above the surface of the water. We have just learned that the fraction of the volume of the object immersed in a liquid is equal to the density of the object divided by the density of the liquid. So it means that if we know the fraction of the volume of the object immersed in the liquid, we can also know the fraction above the water's surface. Then, knowing the fraction above the water's surface, we multiply it by the given volume to obtain the volume of the wood above the water's surface. So this becomes our anchor equation for our solution. In the anchor equation, we are supposed to find the density of the object and the density of the liquid. Since we know the density of the liquid already, let's find the density of the object. We know from the concept of density that the density of the wood, that is MW, divided by the volume of the wood, that is VW. Now let's substitute in the figures. We are going to get 25 kilograms divided by 0.03 cubic meters. When we calculate this using our calculator, we are going to get 781.25 kilograms per cubic meter. And this is the density of the wood. Now that we know the density of the wood, we can find the fraction of the volume of the wood immersed. So the fraction of the volume of the wood immersed in the water will be equal to the density of the wood divided by the density of the water. So let's substitute the figures. We are going to get 781.25 kilograms per meter cube divided by 1000 kilograms per meter cube. And when we write this in fraction, our answer is going to be 25/32. So this is the fraction of the wood submerged in the water. The question is asking us to find the volume of the wood above the water. Now we know from mathematics that total fraction of any object is 1. So if 25 divided by 32 is the fraction of the wood below the water's surface, it means that to find the fraction of the volume of the wood above the water's surface, we have to subtract 25/32 from 1. And when we do that, we are going to get 7/32 as our answer. So 7/32 is the fraction of the volume of the wood above the water's surface. Now, since the total volume of the wood is given as 0.032 cubic meters, we are going to multiply it by the fraction of the volume above to get the volume of the wood above the water surface. So the volume of the wood above the surface of the water will be equal to 7/32 multiplied by 0.032 cubic meters. And when we do our computations, we are going to get 7 times 10 exponent minus 3 cubic meters. When you want to convert this to decimal, we are going to get 0.007 cubic meters. Now let's take our second question. It reads, the mass of a piece of cork is 20 grams. What fraction of the cork is immersed when it floats in water? The density of the cork is given as 0.25 grams per cm cube, and the density of water is given as 1.0 grams per cm cube. So let's find the solution. After reading the question, it becomes very clear that we don't need the given mass to be able to solve the question, since the density of the cork and the density of the water are given. So we are going to use two methods to solve this question, and we are going to compare our answers, because if you have been given the mass of the cork, then we must find a way of using it in our computations. So in our first method, we are not going to use the mass, but in our second method, we are going to use the mass. So method 1, we know that the fraction of the cork immersed in the water will be equal to the density of the cork divided by the density of the water, and both have been given. So let's do the substitution. We are going to get 0.25 grams per cm cube divided by 1.0 grams per cm cube, and we are going to get 0.25. Now let's convert 0.25 to fraction, and we are going to get 1/4. So 1/4 is the fraction of the volume of the cork that is immersed in the water. It becomes as simple as that. Now in our second method, we need to use the mass. So let's write mass of the cork. We are going to represent it by MC is equal to 20 grams. Apart from this relation here, we also know that the fraction of the cork immersed in the water is equal to the volume of the cork immersed, which we are going to represent it by VC, divided by the total volume of the cork, which we are going to represent by VT. So our tasks here are two. We have to find the volume of the cork immersed in the water, and then we have to find the total volume of the cork. Let's find the total volume of the cork, since that one becomes simple. Now we know that the total volume of the cork will be equal to the mass of the cork divided by the density of the cork. So let's substitute the figures given. We are going to get 20 grams divided by 0.25 grams per cm cube, and this is going to give us 80 cubic centimeters. So this is the total volume of the cork. Now to find the volume of the cork immersed in the water, we know that the volume of cork immersed in the water is equal to the volume of water displaced. We have already established that when a body is floating or is immersed in any liquid, it will displace a volume of the liquid, and the volume of the liquid displaced is equal to the volume immersed in the liquid. So in this case, we need to find the volume of the water displaced, and the volume of the water displaced is the same as the volume of the cork immersed in the water. And for that, we can write that the mass of the cork is equal to the density of the water displaced times the volume of the water displaced. Now let us make the volume of the water displaced the subjects. We are going to get volume of water displaced is equal to mass of water divided by the density of water. So let's substitute the figures. We are going to get 20 grams divided by 1.0 grams per cm cube, and our answer is going to give us 20 cm cube. So now that we have accomplished our two tasks, we can find the fraction of the cork immersed in the water. We are going to get fraction of the cork immersed in the water is equal to VC divided by VT. And so by substituting the figures, we are going to get 20 cubic centimeters divided by 80 cubic centimeters. And converting this to fraction is going to give us 1/4, which is the same as the answer we had in the first method. I intentionally made us use this second method because there are some questions that we cannot use the first method to solve. We have to apply some of the concepts we have used in this second method. This is where we are going to end this tutorial. In our next tutorial, we are going to solve more questions on the concept of flotation. Thank you so much and see you in the next tutorial.